Hey guys, so I'm gonna update you on whatever happened last week. Excuse me. On the shop here, so I crashed the machine. I'm still digitizing, and that word I learned it with a friend of mine. And I finished my timing case cover. It was a mess to finish it up, to do the contour or whatever, slot out the material. I was using a quarter-inch end mill, and it was too long standing out of the tool holder. It was vibrating, and it made a mess on the outside. It still looks fine. All my holes are perfect. All that. I thread mill, over there. Hope you see it. I don't know. All my threading is beautiful. Oh my god. All the threading is fine, so the timing case cover is done. I'm waiting on my stock to finish my little covers. I want to make them out of round pieces. I don't want to use my square material to do them round parts, so I ordered some flat round stock. I mean some, yeah, wedges. I mean, I don't know, round stock. And right now I'm digitizing this. Yes, that's what it looks like. It's the front part of a Cummins block. And I forgot to show you that I have been digitizing the front of that block so I can get all my holes perfect. That's what I did with my timing cover. Even though I had a basic of whatever it was, because I sent it a timing case over to a friend of mine and he scanned it. I wasn't really happy. This what came out. This is the first one that came out when I first cut it. So this holes right here, and I had a mistake here. I hope you see that here. But anyway, I did cut the front of the block, machine it, face it on the back side. Pretty much, it's perfect square. I machine on this machine. That's why the coolant looks so ugly, and I don't know if you noticed that, because I did that cast iron here, and it messed up my coolant. I'm not gonna change it right now. But anyway, so what I'm digitizing right now is I already got my 0 on my X here. I got my Y on this face, and what I'm about to do is I'm gonna mount the original timing case out of a common rail uh, engine, and I'm gonna get my 4 holes for my pen. I'm gonna draw them here. Gonna draw them holes on my timing cover, here. So yes, that's pretty much what I'm doing. I'm gonna digitize those 4 holes once I mount my timing case over there, and draw them here on that timing cover, which is the same one, timing case, which is that one there. And that way I know where they are from the factory. Excuse me, sorry, I'm tired. And another update is this. I destroyed my spindle orientation setup. So what happened is I had the machine on the spindle orientation, so pretty much I had the spindle locked with the plunger and the bearing, which you guys already seen that, and I did a spindle on, forgetting about it, inside my, see, because I got my probe in it, I don't want to make a mess. Inside this bottom right here, my spindle on and off, there were just only that, pretty much on and off a spindle, and there was not an M3. Inside my M3, I got safeties for that. It will not allow my spindle to come on if I get some of the inputs and all that. So what I did now, I turned that bottom into a script bottom. So pretty much, come on, there's a script inside that bottom now. But it didn't used to, but now there's a script, and the scripts have some safeties on it, like if it's triggered my OEM trigger 4, it will not come on. If my output for my solenoid on my orientation is triggered, it's not gonna come on either. And if my 299, which is that one there, is on the spindle, it's not gonna come on. And then if all of that is okay, then we're gonna on and off if we press on that button. So that part is done, and the other part I wanted to show you oh my god, is feed hole. So most people know, if you do some research, Mach 3 and feed hole for some reason, and I have problem with it, and I don't even use it. What I do, I delete that bottom out of there, pretty much. But I was using something regularly, and it was like feed slow down, if I can say it like that. So what I was doing, I was coming in here and slowing down my feed very low to see what was going on the machine, right? So that being said, what I did is I created a small macro, a little bit of macro. It took me 2 days to get it, because you guys know I'm not good at it, but I finally did it. Okay, the only thing that was killing me, I'm about to show you right now, was killing me bad. If you look at the script, this is the only thing on it. I hope you can pause the video and look at it later and put it inside your feed hole bottom if you got a problem like I do, or if you want to hold down your machine and look at something or clean some chips or whatever. So I was just slowing down the machine. Right now, if I click on feed hole, I actually do not hold the machine. What I do, I slow it down to 1%. If you see it right there, slow it down to 1%. So what I'm doing is I'm setting up my DRO 821 to 1, which is this DRO right here. That factor, come on, that factor DRO, which is the percentage of the feed rate. Slow down to 100, or set it back to whatever it was. And like I said, right now, that was my biggest problem. I didn't know how to store that information somewhere that I could use it later, and it kicked me for 2 days. And it was, on my case, the only way I found to do that was create a DRO. So I created this DRO right here, and this DRO, what it will do is, when I first click on that bottom, it will set, using that, let's say I'm gonna turn this down to 60%. You see it right there. Just turn it down to 60%, and let me close this. And I come here and I run that macro. When that macro ran over there, you see that it set that DRO to 60, because that what my DRO was. It was a 60. If I run it again, it puts my DRO to 60 again. So it first put it to 1, and then it put it to 60. If I even decrease this DRO even more to 30, and I run it, it's gonna store 30 right here. And if I run it again, it's gonna set 30 on it. So the point was, I could always set it to 1, but then if I reset it, it will go to 100. Like doing this bottom right here, reset, it will go to 100, and that's not what I wanted. Because what if I was running good at 50%, and then I wanted to keep going on my feed hole, if I wanted to keep going on my feed hole, then I was going to 100%, not to 50 like I was. So that was the way I fixed it. I mean, I was able to do it. You see, now I got 100. I got to make that deer a little bit bigger or less numbers. It don't make sense having that many on it. But I will fix that. That's not a problem. But yeah, there is 100 over there. And so you see, right now it's a 1. If I do it again, it's a 100. So that is the way I found to slow the machine, very slow, clean some chips, do some stuff in it. This way I found to kind of control Mach 3, slow it down while I'm doing some work and still be able to clean some chips or do something on it while it's still running almost like feed hole. Feed hole doesn't work at all on Mach 3. At least for me, it hasn't worked where I feel safe doing something with it. So I did it that way, slow it down to 1%, and then send it back to whatever it was, and you can keep doing that as many times as you want. It works good. It's got some, I would say, downside or not. See, on my case, I never lock my my rapid to my feed rates. So what happened with that is, when you slow down to 1%, and let's say you slow it down pretty much to the right at the end of your tool change, it's actually going to go ahead and do all the tool change pretty quick, which that's something I like. It's going to do the whole tool change pretty quick, you know, and once it's ready to start milling, then it's going to, which is, you know, it went out of feed rate, it's on rapid mode pretty much. It's going to do it all fast, and then when it's ready to feed rate, it's going to slow down to 1%, or it's going to stay at 1%. Even though it's showing 1%, it's still going to do all the tool change pretty quick. If you just change that setting that I just showed you, locking your rapid to your feed rate, it will slow down everything. Tool change, carousel, all the good stuff you guys know. And I do not like that. I want my tool change to be done fast anyway. And yeah, that's it. Well, those are the updates. There's some good, and some are not that good. That one is good, and this one is bad. The cover is good. I like the cover. Oh, I'm gonna show you something else back here. Was just thinking what I'll show you. Like, you see how my oil separator or whatever is working like. You see how clean my coolant is here on that reservoir, and how dirty is up here, and on the outside is dirty. So that means that pump is pumping oil from that area over there, even though the pump is that $20 wet saw pump. No good. I gotta put a bigger one. That is the little bitty one. It was too small. It's not enough. But that's it, guys. It's working. I got oil up there, and that area is clean. So I am putting oil on that area. Someday it's gonna get filled up, and I'm just gonna. I actually was, like I said on the video when I was building this, I wanted to do a hole with a drain that I can just put something down here and drain it. But honestly, I wasn't sure it was gonna work. So now that I know it's working, if I clean this tank, because I'm gonna have to clean it. I machined that cast iron here, and it messed up all my coolant. If I clean the tank, I'm gonna go ahead and drill that, put a drain on it where I can just open that valve and drain the oil out of that, you know, that area over there, over, you know, to something. Other than that, everything is good. And I guess I'll see you in the next one. I hope you get some good information out of what I just told you. Like I said, that was the best way I found, and it took me 2 days and a half almost to just to do that little bitty code. But yeah, and realized that I needed a what do you call it, DRO over there. So, all right, guys. Well, see you in the next one. Thank you so much for watching. Bye. Okay, guys. So on the previous video, I had that block or front of the block, you know, facing on the Y, but I figured I didn't have enough room so I can thread my cover once it's mounted on it. So I was coming way too much out of the Y-axis travel. So I put it on X, and I just line it up here. I'm gonna center, get my Z-axis, my Y-axis around this pin right here. This bolt is holding that pin too, that dowel pin or whatever, and my X is gonna be here on this face, just like I said on the previous video, but I was on Y. So let me just move it. I'm gonna have to hold this camera. I don't know if it's getting hot or what, but it just cuts off whenever it wants to. So I'm gonna do some Z-axis slowly. Whoop. So I'm gonna get my Z here. Are you sure? Yes, I'm sure. Z-axis. Okay, that's my Z-axis right there. And I know where my Z-axis is, 719. So I'm gonna drop down lower than 500 because that's what my setup is here. My surge depth is 500,000. So I'm gonna come off the area on the X, because I'm gonna get my X now. I'm gonna drop on my C lower than 5. So around 300, that's fine. And then I'm going to get my X here. Yes. Okay, we got our X. Then we just got to get our Y, but we're gonna get our Y here on this bolt right there. So I'm gonna come off X anyway, again, and I'm gonna get in on Y, like I'm gonna kind of get on top of it. I'm also gonna drop so it kind of drops around 500,000 from the stylus to the middle of the bolt. This is not perfect. These are just open bolts, and 2 or 3 thousandths one way or the other, it'll be fine. It's not a big deal. So, and then there I'm gonna do a Y on 0.4. So I'm gonna be traveling 0.4 that way and 0.4 this way. So I'm assuming it's got around 800 thousandths. This pin is around 800 thousandths, so I will not touch I will not break my stylus. So let's send it. Okay, there we go. Get that in. And there it is. So we got our X, Y, and Z. So I'm gonna bring my C a little bit higher, and if I click on bottom, you guys saw that we got ready before. We're right on X and Y, and Z doesn't move, but we're right on X and Y right there. So we're on the edge of X and on the center of the pin on Y. So now I'm gonna mount the cover, that cover right there. I'm gonna mount it on, so I already got this hole, and I'm gonna digitize this bolt and this bolt and this bolt and this bolt, and I'm gonna draw it like I said on the cam program, and I mean on the CAD program, and then we're gonna cam that and come here and drill and thread mill them holes with the timing cover or timing case on it, which let me see. So I got to drill them holes right here. So I'm gonna mount this on the piece of block and tap and drill. I mean drill and tap them bolts. All right, I'll be back. Okay, so I got my 4 holes lined out with my x-axis, so I can just draw over there whatever, you know, whatever these holes are, and I'm done with it. Now I'm gonna take this cover off and mount, I mean this case off, mount the one we built, and just program over there cam, you know, drilling and thread milling whatever I'm gonna do over there, and then I can just put it back on the block and we're done with it. Alright guys, wait. Okay, so now I got the timing case set on the block. I already reline up everything, make sure everything's lined up, but I had a situation. I'm really close, I mean not that close, but on my tool change it get really close, so I don't want to run any risk. So what I did, I went into my M6 and changed the coordinates on a tool change. So pretty much anytime I'm going to change the tool, my table is going to move out of the way for my tool change, which is, that's something normal for many cases, but I wasn't doing it because I never put a really tall workpiece on or whatever. So but this is pretty much how it works. I'm gonna pick up tool just right beside that one, 79. There it is. So from there on, you know, the code is gonna keep going, but on the tool change, the table is gonna move away and then come to the work offset or whatever. mistake. I'll be fine. Yeah, I'd rather be like that. That's the lowest one. Well, it's done.